Welcome students to this new video on differentiation for the class 12 students of maths. This is exercise 1.2 and we shall discuss the questions from question number 9. These are all to be differentiated with respect to x, but if you look at the top line, these are the questions we are going to deal with. See, cos inverse of 1 minus x square upon 1 plus x square, sin inverse. Trigonometric arrangements can be made here. If you look at the expressions inside the bracket every time, this looks like certain formula. 2x upon 1 plus x square, also it looks like certain formula. Half angle, double angle, triple angle formulae, allied angle formulae. These all formulae are with you. If you remember these formulae, like here also, the quantity or the expression inside the bracket has to be looked at. And for understanding it better, I have given some ready formulae. So this 1 minus x square upon 1 plus x square looks like 1 minus tan square x upon 1 plus tan square x, which is cos 2x. So if you see this example like this, it will become very simple. Cos inverse cos 2x is simply 2x. Understood? Similarly here, 2. If you write x as tan x, you can't do that. You have to write x as tan theta. It looks like this formula. This expression looks like this formula. So you remember certain formulas looking like this. These are not random expressions inside the bracket. These expressions are special ones. 1 minus tan x upon 1 plus tan x. That's how it looks like. 3 tan x minus 4 tan cube x. That looks like sin 3x. Even you can think like cos inverse of 4x cube minus 3x. Here 4 cos cube theta minus 3 cos theta is cos 3 theta. So you can have cos inverse outside and similar questions will be there. So let us solve these questions, and to solve this I should put x is equal to tan theta here. So instead of x, I would read tan theta. This will look like 1 minus tan square theta upon 1 plus tan square theta, which will be cos 2 theta. And not like this x, just read this as theta, and then you would understand 1 minus tan square theta upon 1 plus tan square theta will be it will be cos 2 theta. These formulae are in terms of x, but you can write x is equal to tan theta, and you have to write x is equal to tan theta there, not tan x. X cannot be put as tan x. X should be written as something in terms of some other variable theta. So x is equal to tan theta is the substitution required in that example. Here x is equal to again tan theta. 2 tan theta upon 1 plus tan square theta is sin 2 theta. That suits here. This is the formula in terms of x. So you have to use it in terms of theta. Here also x is equal to tan theta will work. Then it will become tan pi by 4 minus theta. Here x is equal to sin theta will work. X is equal to sin theta, because in that case you would read the formula as 3 sin theta minus 4 sin cube theta, which is sin 3 theta. So if you write x is equal to sin theta, this will be sin 3 theta. And if sin 3 theta is there and outside sin inverse sin 3 theta will be simply 3 theta. So this is what we shall do. These all examples are based on substitution. So substitution method, that is the topic, or that is the part we shall discuss in this lecture. See the first example. Y is equal to cos inverse of 1 minus x square upon 1 plus x square. What we shall do is we shall substitute. Put x is equal to tan theta, because we discussed it. It looks like the formula 1 minus tan square theta upon 1 plus tan square theta. This formula is going to be useful. 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. This formula is applicable. But whenever you put x is equal to tan theta, remember you have to write theta's value. Therefore theta is equal to tan inverse of x. So you require that value later on. Now coming back to y, y is equal to cos inverse of 1 minus, we are writing x as tan theta, so 1 minus tan square theta upon 1 plus tan square theta, which is equal to cos inverse of, just remember this formula, cos inverse of cos 2 theta, which is cos inverse of cos 2 theta is just 2 theta. So y is going to be equal to y is equal to 2 into theta means what? Just get back to this value. Theta is equal to tan inverse x. So 2 tan inverse x. Now y is simple. This was the original y expression. Now we have got y like this. So see how much simple it has become. Therefore, differentiating with respect to x after this step gives us dy by dx is equal to 2 tan inverse x is derivative. 2 is a constant that comes out, and derivative of tan inverse x is 1 upon 1 plus x square. So you can consolidate this all as 2 upon 1 plus x square, and this is dy by dx. So this is the formula we used in this example. So every time you would find similar kind of a formula if you compare that expression inside the bracket, which is non-trigonometric expression. So it's inverse trigonometric function with non-trigonometric expression inside the bracket. This is the type. You have to remember this. Now consider this example. Y is equal to tan inverse of 1 minus x upon 1 plus x. We have to differentiate it with respect to x. But like I said, inverse trigonometric function with the bracket containing non-trigonometric expression. So here you have to use some trigonometric substitution, and that is decided by some formula. What is the formula similar to this? 1 minus tan theta. You have to remember it in terms of theta. 1 minus tan theta upon 1 plus tan theta is equal to tan pi by 4 minus theta. So remember this formula. Tan pi by 4 minus theta. 1 minus tan theta upon 1 plus tan theta is tan pi by 4 minus theta. So what we shall do is we shall put this x equal to tan theta. So let's start it. Put x is equal to tan theta. Therefore immediately write theta is equal to tan inverse of x, and therefore y is equal to tan inverse of 1 minus x is tan theta divided by 1 plus again tan theta, which is equal to tan inverse. Now 1 minus tan theta upon 1 plus tan theta, this is tan pi by 4 minus theta, which means it is equal to tan inverse of tan of the bracket is that bracket. So it is pi by 4 minus theta. Finally, once you simplify the expression in terms of theta, just remove this theta and write its value. The value of theta is tan inverse x. So y is equal to y is equal to pi by 4 minus theta's value is tan inverse x. So once you find y in the simplest form, this is the simplest form of y we wanted. This was the original form of y. See how much difference is there. If you look at the two expressions, this is very complicated to differentiate. This one is easier. So differentiating with respect to x, we get dy by dx is equal to derivative of pi by 4 constant, so 0, minus derivative of tan inverse x is 1 upon 1 plus x square. So if you write this all together, it will be 1 upon 1 plus x square. Dy by dx is equal to this much. So this is the answer which we wanted. Now see this new example. Sine inverse of 4x cube minus 3x is what you have to differentiate with respect to x. So we shall write that y, let y is equal to sine inverse of 4x cube minus 3x. Here we shall put x is equal to, now you have to remember the formula. Which formula looks like 4x cube minus 3x? It will be 4 cos cube theta minus 3 cos theta. This formula is known to you, which is equal to cos 3 theta. So we shall use this formula and put x is equal to cos theta in it. Therefore theta is equal to cos inverse of x. Therefore y is equal to sine inverse of 4 cos cube theta minus 3 cos theta, which is equal to sine inverse of 4 cos cube theta minus 3 cos theta is cos 3 theta. Cos 3 theta. Now this is slightly different. We are familiar with cos inverse of cos 3 theta. If it is sine inverse of cos 3 theta, still we can manage it. We have solved similar questions earlier. So what you do is, don't change this sine inverse, it remains as it is. Just this cos 3 theta goes, and that is replaced by sine of what? Cos 3 theta is equal to sine of pi by 2 minus 3 theta. So replace this cos 3 theta by sine pi by 2 minus 3 theta, which will be equal to then sine of, in sine inverse of sine of the bracket is that bracket, that is pi by 2 minus 3 theta. This is y. Therefore now we have got y in terms of theta. Get back to original form of theta, which is cos inverse x. Get it in terms of x. So this is pi by 2 minus 3 into theta is, like we discussed here, cos inverse x. Therefore we make that arrangement early. While substitution is going on, we equivalently write theta there. This is why in the final simple form in terms of x. Now differentiating this with respect to x, you will get dy by dx is equal to pi by 2 derivative, constant derivative 0, minus 3 into derivative of cos inverse x. Derivative of cos inverse x, you know, is minus 1 upon root of 1 minus x square. So finish this everything as dy by dx is equal to minus 3 upon root of 1 minus x square. So this is the answer for this question. Originally formula has to be understood. This expression inside the bracket 4x cube minus 3x looks like this formula. So this formula was used, and for that formula to be used I had to put x is equal to cos theta, and then I get it sine inverse of cos of something. So that problem is also discussed earlier. Sine inverse of cos of something is there, then you can convert it into sine inverse of sine of pi by 2 minus that given angle. So then everything is known to you. Like this it is solved. We are solving examples from exercise 1.2, question number 9. These are few more examples. You can see the first example written in this list. Sine inverse of 1 minus 25x square upon 1 plus 25x square. Other one is there, sine inverse of 4 raised to x plus half whole divided by 1 plus 2 raised to 4x. A few more examples are there in question number 9 in exercise 1.2 of the same type. See, look at the first example. I have written it y equal to, you have to take it as y equal to sine inverse of this whole expression. Now this expression inside the bracket, it looks like certain formula. Which formula you think is likely to be used here? It is like 1 minus tan square x upon 1 plus tan square x is equal to cos 2x. This is the formula we remember, which is similar to the expression inside the bracket. So it will be better if I write tan x is equal to in this case, this is your tan x equal to 25x square's root means 5x. This will be better seen as sine inverse of 1 minus 25x square is 5x whole square upon 1 plus 25x square, again written as 5x whole square. Now the formula and this expression, if you compare, this tan x is 5x here. So I can remember this formula in terms of theta. So 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. So I will put tan theta equal to 5x here. Tan square theta means theta is tan theta is kept as 5x. So if you do that, put tan theta is equal to 5x. Immediately you should understand that whenever you put tan theta is 5x, theta is equal to tan inverse of 5x. We shall use this arrangement later on. Now get back to your expression of y. Y is now equal to sine inverse of 1 minus, now 5x is tan theta, so it is tan square theta upon 1 plus, again 5x square means tan theta square, that is tan square theta again, which is equal to sine inverse of, this is nothing but cos 2 theta, which is sine inverse of cos 2 theta. We can make arrangement. Sine inverse of sine 2 theta would have been fine, would have been what we had required, but cos 2 theta can be written as, sine of pi by 2 minus 2 theta. So you can make this arrangement anytime, pi by 2 minus 2 theta. So right here, sine of pi by 2 minus theta, sine inverse of cos 2 theta written as sine of pi by 2 minus 2 theta. In this manner, we can write in a simple form as pi by 2 minus 2 theta. This y will be written as y equal to pi by 2 minus 2 into theta is tan inverse of 5x, tan inverse of 5x. Now this is y in the simplest possible form. Now we shall try to find derivative of this expression. Differentiating with respect to x, I will get y's derivative with respect to x, dy by dx is equal to derivative of pi by 2, being a constant, derivative is 0, minus 2 tan inverse x, derivative 2 is constant, and tan inverse 5x, 2 is constant kept out of the differentiation. Into derivative of tan inverse 5x is 1 upon 1 plus 5x whole square, which will be 25x square, into d by dx of 5x, which we know how to find it. So 0 minus 2 into, so I shall write directly minus 2 upon 1 plus this 5x whole square is 25x square, and into d by dx of 5x is 5. So finishing this answer as minus 10 upon 1 plus 25x square. In this manner we solve this by using the trigonometric formula of cos 2 theta. Cos 2 theta formula is 1 minus tan square theta upon 1 plus tan square theta. So you have to put tan theta is equal to 5x here. Always make arrangements in terms of substitution, etc. When you try it as tan theta is equal to 5x. Normally students make mistake by taking tan x is equal to 5x. That doesn't work. It's not done like that. You have to take some different variable, not x. You have to take theta or something different, phi. Normally we take theta. Understood? So while substitution, make sure that you are putting theta, not x. Original example is in terms of x, so you have to use something different from x. So tan theta is taken as 5x. Now see the next example, which was written here, number 2 now. Y is equal to sine inverse of 4 raised to x plus half whole divided by 1 plus 2 raised to 4x. We shall make it a little bit simple. I write this as sine inverse of 4 raised to x plus 2 is 4 raised to x into 4 raised to half. 4 raised to x into 4 raised to half divided by, I can write this 1 plus 2 raised to 4x can be written as 2 raised to 4 raised to x. This is written equal to sine inverse of 4 raised to x, and this is 2 raised to 4 raised to x. I have to make some arrangement. Now 4 raised to half is 2. This is 2. So I may write that as 2 into 4 raised to x. This 2 is come from 4 raised to half. 4 raised to half is 2. 1 plus 2 raised to 4 means 2 raised to 4 is 16. 16 raised to x. Now do you imagine some formula looking like this? The quantity inside the bracket. 2 tan theta upon, this is 2 tan theta upon 1 plus tan square theta is sine 2 theta. You remember that. Now if you compare these two expressions, you feel that 4 raised to x is going to be tan theta. And if this 4 raised to x is tan theta, then this should be tan square theta. How do you see this 16 raised to x? 16 raised to x means 4 square raised to x. 4 square means 16 raised to x. So 4 square raised to x means further I can write that as 4 raised to x raised to 2. A raised to m raised to n is written as a raised to n raised to m also. Now it looks like this. 16 raised to x will be replaced by 4 raised to x raised to 2. Then the formula would look obvious. Sine inverse of 2 into 4 raised to x divided by 1 plus this 16 raised to x as per these arrangements can be written as 4 raised to x raised to 2. Now look at the formula. Look at this formula. This is this formula. 2 tan theta upon 1 plus tan square theta is equal to sine 2 theta. So I have to put, this is y. So what do? Put 4 raised to x is equal to tan theta. And if you put 4 raised to x as tan theta, theta is equal to tan inverse of 4 raised to x. Now therefore y is equal to sine inverse of, now this is what I am trying to write in terms of theta, 2 into 4 raised to x is taken as tan theta, so 2 tan theta divided by 1 plus 4 raised to x square means tan theta square means tan square theta, which is sine inverse of 2 tan theta upon 1 plus tan square theta is sine 2 theta, which is sine inverse of sine 2 theta is simply 2 theta, which is 2 into what is theta? Theta is tan inverse 4 raised to x. This is y in the simplest form. Now differentiate with respect to x, and you'll get dy by dx is equal to 2 tan inverse 4 raised to x. So derivative 2 is a constant kept out, and derivative of tan inverse 4 raised to x. It's like tan inverse x is derivative 1 upon 1 plus x square. So it will be 1 upon 1 plus x square is replaced by 4 raised to x square. Okay. So into d by dx of tan inverse x compared with tan inverse 4 raised to x. So derivative of 4 raised to x should be written extra. This is 2 upon 1 plus 4 raised to x raised to 2 into this derivative is 4 raised to x log 4. 4 raised to x log 4. So I can finish this as 2 into 4 raised to x into log 4, that's the numerator completed, divided by, in the denominators we have 1 plus, I may write this as 1 plus 4 raised to x square means 4 raised to 2x also, or 4 raised to 2 raised to x, all are fine. What is this value going to be? See, it is 4 raised to x square means 16 raised to x means 2 raised to 4 raised to x means 2 raised to 4x also. These are all equal. You may find any version. You may stop here also, 4 raised to x square or 4 raised to a raised to m raised to n is a raised to mn. I would write that as 4 raised to 2x. 4 raised to 2x. So dy by dx is written like this. 2 into 4 raised to x log 4 divided by 1 plus 4 raised to 2x. So you can practice similar examples from the question number 9 in exercise 1.2. Some arrangements are required and some trigonometric formulae will be helpful there. So practice those examples at home. This is going to be end of this session, and in the next session we shall see question number 10 in the exercise 1.2. Thank you.